Hi, I'm Mr. Evans, and in today's video we're going to focus on the difference between distance and displacement. So I want to start with distance, and when I think of distance, I think of how far you've actually traveled, and so this means the path you choose to take actually matters. And so let's say we start here, and I'll put an S to mark that we start here, and we decide to walk 10 meters east. But then we turn around because we realize we missed our destination and we walk 3 meters back, and then we are at our finish line. You know, the actual distance we covered totals in 13 meters. The reason why? We walked 10, we walked 3 more, and so we walked 13 total meters. Okay, the difference between distance and displacement is displacement doesn't care how you got there. It just matters where you started from and where you finished. So in this case, and I'll use a different color here to represent displacement, you know, we started here still and we finished here. And so for displacement, you just draw a straight line from where you started, straight line to where you finished. In this case, our displacement is 7 meters. Even though we walked a total of 13, and at one point we were even 10 meters away from our start, our total distance is 13 because we walked 13 meters. Our total displacement is 7 because if I was to call someone from where I was and they asked, well, how far away are you? I would say I'm 7 meters away because a straight line would get you there in 7 meters. Now we're going to look at another example to discuss the difference between distance and displacement. And so what I've drawn here, or have attempted to draw, is a track. And so for anybody that hasn't run track before, one loop, if I were to run an entire loop around the track, is 400 meters. Okay, and so this would mean 4 laps around the track would be 1,600 meters, which for any of you mile runners is your race. So if I were to say I'm going to go on the track today and run 1 mile, I would run 4 entire laps. Okay, and so let's say I've done that, and so I start here at the finish line, and I'm going to run 4 laps. And I'm just going to draw as 1 lap because this will get crazy if I draw this 4 times. But I run 4 laps, and now I'm finishing my 4th lap, and boom, I finish at the finish line because that's where you always finish. Okay, now I've run 4 laps around the track, and so my distance, remember, is how far I've traveled, and I have traveled a mile. Okay, and if you've ever sprinted a mile on a track, you'll know you ran a mile because you will be exhausted. You might not even be able to stand. So I have definitely traveled 1 whole mile. I have traveled 1,600 meters, and that is my distance. So your distance is 1,600 meters. You ran 4 laps around the track. Now the issue is, well, you know, that's great. What is my displacement? And if you remember, displacement is where you started and where you finished. So in this case, I started here, ran 4 laps around the track, and finished right here in the same spot. And so if I started here and finished here, what do you think my total displacement will be? Well, it will be 0 meters. So even though I ran a whole mile, my displacement is actually only 0 meters, because if somebody hadn't watched the race and they just saw where I started and where I finished, they would not have known that I moved at all. Alright, so now I want to finish with one more example here, and we're going to cover movement in 2 directions. Okay, and so in this scenario, let's say we've walked 4 meters north and 3 meters east. Okay, now your distance, hopefully at this point, isn't too difficult to figure out. Right, your distance is strictly how far have you walked, and you walked 4 meters, you turned and walked 3 more meters, and so your distance equals 7 meters. Okay. Now your issue is, in this one, is your displacement. And so in your displacement, you started here and you finished here. Okay, so if I drew a straight line from start to finish, well, I can't just look at that and know how far that was. Okay, and so there must be some kind of equation I can use to solve for that line. And now if you've noticed here, what I've really done is made a triangle. Okay, and if you've taken enough math classes, you'll know that to solve for this side here, you can use the equation a squared plus b squared equals c squared, with c representing your unknown line, which is your displacement in this case. Okay, so we're going to solve for this. In this case, a squared, a is 4 and b is 3. It doesn't matter which one's which. All that matters is that you recognize that c has to be our unknown. And so in order to do this, we'll just do 4 squared plus 3 squared equals c squared. Okay, and now you could use a calculator, you can do it in your head, it doesn't matter to me. And so 4 squared is 16, 3 squared is 9 equals c squared. And I'm kind of running out of room, so I'm going to start working over here and I'll draw a line for you. And so now we have 25 equals c squared. Well, how do I get rid of that squared? The opposite of squared is square root, and so we're going to do square root of 25 equals square root of c squared, and so c equals 5. And so what that means in this case is your displacement, well actually, so let's first, so 5 goes here on this line. If 5 is a straight line from start to finish, your displacement is 5.